Hi, I'm Mark Wilson, the Engineering Heretic, and today we're going to look at gears, and in particular we're going to look at this particular gear here, which is from my lathe. It's a 45 tooth. It says here that it's metric module 1.5, but we'll do a little few calculations to check and make sure that is the case. But what I want to look at is also this particular instrument here, which is a gear tooth measuring caliper. It's imperial, but that doesn't make any difference for what we're doing because we'll just convert here. We're talking about metric gears here, not diametral pitch, which is the imperial gears. But we'll cover that a little bit too, so you should be able to work out what's going on. Now, all gears, I'll just move this a little bit here. All gears can be expressed in a rack form. And so I've done a bit of a sketch here. The pitch from one tooth to the next in rack form here in metric module 1, or diametral pitch if you really want to split hairs here, is 3.1416, which of course is pi. The depth to the pitch, or the halfway point, or if you had a gear in here, would be the pitch diameter, which is the engagement point between the two gears. The depth here is 1. And the depth to, if another gear was engaging down here, would stop around about that point there. That is also 1. The hole depth here is another 0.25 here, so 0.25, and so your hole depth is 2.25 millimeters. So that's the theory here. So that half way down here is 1. Another 1 for the other half, because the reverse gear that goes into here comes down in that section here. So basically, you think of a gear upside down in here, kind of works the same way. Now, with that in mind, we would like to see if we can work out what this gear is and find out what the module is. So, in metric module, this says it's 1.5, and I know I said before that was the figure of pi, but this is actually a measurement. That's 3.1416 millimeters, or 3.1416 inches. Right, now this particular gear, we want to work out what that actually is, and there's a formula for that, and the formula is another thing too, sorry, before I go any further, there's a pressure angle on a gear, and that's this angle here. And that can be 20 degrees or 14.5. Now, a lot of imperial gears, very old imperial gears, are 14.5. Quite often they are the 20 degrees these days. The reason why 14.5 was important in the past was if you had a triangle here and that was 4 inches here, 4 inches, and you put a 1-inch slip gauge underneath your sine bar, the angle there would be very close to 14.5. Okay, so that's in the days before they had calculators and stuff like that. They could very quickly come up with 14.5, and that's why in Acme thread form you see that that particular angle there, which is basically using the same formulas as this, except that the pitch is that figure of pi. Now, we also want to calculate and find out what this particular gear is, and that calculation is what is it? Hang on. It's the module equals number of teeth plus 2 by, it's divided, is it, by the OD. I think it's divided by, actually, divided by the OD. Okay, In this case here, and the reason why that little +2 is there, because this will, if you count the number of teeth on this, you'll find out that you'll calculate the pitch diameter of the tooth. We only really can measure quickly the OD. So we add one side, which is the factor of 1, and the other side, because it's round, we put another one. So the number of teeth +2 will give you the outside dimension. Now in this case here, my size is, it's 45 plus 2, which is 47. The OD here is 70.5. And if you do the calculation, that comes down to, if you work that out, it comes down to 1.5. Now, if you measure the OD and it's not exactly right, if it comes down to something like 1.9746 or something like that, very close, you just round it off because the overall dimension may not be perfectly correct. If it's a weird size, then instead of doing the divide, okay, do the same formula except you multiply, which will give you in diametral pitch. Now, let's get back to this little tool here. I'll just move my camera. This tool will give you the measurement, I'll go back to this one, will give you what this measurement is across here and the depth down to there. And you can measure that with this particular tool. But what happens in a gear is that this all becomes bent, and the next tooth around here is now on a radial thing here, and of course the pitch on metric module 1 from there around here on that point there around caudal, around the arc there, is 3.1416, which is pi. And of course we know we're going to multiply that by 1.5. So every time you add another tooth to a gear, you add that figure of pi in the equation. Now most transmission gears started around about 12 and go up from there up to, bigger and bigger and bigger, 144, then they go up to even racks and things like that. But every time you add another tooth, you add another factor of pi to that, which will give you the multiples of teeth. Now, because that curve changes, if you're in rack form here, when you bend that around a gear here, this becomes curved, that becomes curved, and this pressure angle here becomes sort of bent in a weird sort of shape called an involute curve. And if you wrapped something round around a curve and you unwound a string around it, that unwinding of the string would strike this particular curve called an involute curve. Now most gears have an approximated radius on them, but we'll deal with that another time, but that's just by the by. Now, to work out the size, we need to know the depth from this point here, the top of that arc there, to this in a straight line across here where that pitch line comes through in a straight line there. We need to know those two sizes there. And they become the S dimension, which is the size from this top of there down to here, which is the S dimension, and this one across here, which becomes the T dimension. And in this case here, we need a chart. Now, if I look at my chart, this chart works for metric module as well as diametral pitch. You just read them in inches or you read them in metric. It makes no difference. And it doesn't make any difference about the angle of the pressure angle, because although that swings around here like that, it makes no difference to that intersection point here, because that swings from that arc there. So all we need to know, we don't need to know the pressure angle of this at all. We just need to calculate what this is. Now, on my calculations, I come up with, if I look here at a 45 tooth here, I end up with T equals 1.5705 multiplied by, we found out this is a diametral pitch of 1.5 by 1.5, equals 2.355. But because this is also an imperial measuring thing, it works out to 93 thou. 93 thou. 0.93 thou. And the T dimension becomes the S dimension, which is this one down here. The S equals, on this chart here, is 1.0137 by, of course, the module is 1.5, comes down to the figure of 1.52 millimeters, and that equals 93 thou. 60 thou. Right, so we've come up with those figures here. Now that we've got those figures, we can now grab our gear tooth measuring device here, and I've set that, because it's imperial, I've set my depths here, and I use this like a gauge. I actually set this and then hold it on the gear and just check. We do need to factor in one more thing on this particular gear, and that is clearance on the T dimension, and we take 3 thou off this one here for clearance, so that becomes 90 thou. So I've set this here for the T, which is 90 thou here, and the S, which is the depth, there for 60 thou. And now I've got this set ready. It has carbide tips, so it will measure right to a sharp edge, and that's why they have carbide tips on the width one here, not so much on the depth. So if I get my gear that I want to check, and I put this on here, I find that this depth here is perfectly in line with that. That is the exact size of that gear, so we worked out that that gear measures up with 3 thou clearance. It is a metric module 1.5, and we've come up with, that's what we worked out. It's a 45 tooth there, and that is how you read gears with this particular instrument. There's another method for doing that, and that's a span method, and I'll talk about that. There is a way of actually working out the dimensions over a span of teeth there. I'll talk about that in another video. And I'm Mark Wilson, and thanks for watching.